Hi everyone, my name is Henry Tamun. I'm the IT coordinator for South Sudan. Welcome in this short video report on IT in South Sudan.
My name is Joseph Doe. I'm the IT officer for the program.
Three of our offices up north in the country. We have Kaya and Jamal next to each other, and Malakal, Rumbek, and Juba. This is the setup of our systems in Juba. We are getting internet through a 2.8 meter dish with a bandwidth of 512 and 1536 kbps, one-to-one contention. Two modems are connected to the VISA. We have a TX and RX modem, and they're connected via a heartbeat cable. These two modems are sending down to a switch. This switch helps us distribute internet to these two segments of our network. We're splitting the internet into two. On the right hand side we have the OGN. We have a Cisco switch here, which is sitting between the distribution switch and the access switches which we have here. This Cisco switch is connected both to WAN and LAN. On the LAN side we have this network, which is 10.128.110.x, where we have all our users behind this, and our server is also connected to the same network. Our server, which is having the AD, the DHCP domino file server. The name of the server is SSJBA DC01, and this server is actually giving DHCP to all users under this network subnet, and all our users on this subnet, they are cable users, and they are under OGN. On the other side, we have all affiliates on this side. They're actually connected via a Wi-Fi, which is directly connected to the switch and directly connected to the modem. So we can assume that it's actually coming straight from the modem. And they are actually under 192.168.1.x network. They're actually a cyber cafe setup. It's directly going, their traffic is going directly to the internet. Why? Because in the past, everyone used to sit on this side of the network. And as you know, our traffic goes on a VPN tunnel, which is going from here and then goes down to Oxford. Let's put this one Oxford. And from Oxford, it's going as a VPN and then goes through the firewalls and then to the internet and then all this way, and it goes to the HQ of respective affiliates. This long route of packets causes some real problem with the exchange servers, and it times out. Most of the time they can't download their files, they can't access their mails. So we decided to split the network into two to make it possible for them to access. Since this is actually not a manageable switch, it's just a Cisco business, small business switch, and you can't create VLANs and you can't create anything. So we are doing hardware splitting of the network, so we have both networks. The problem is solved. Let's go to our next office, which is actually Jamam. Jamam and Rumbek, they have identical setup. That's why we just summarize them into this one slide. We have 2.8 meter dish with 128 to 256 kbps, 1 to 8 contention each to the two offices. The connection comes down to a modem, and a modem connects to Expand, and the Expand now connects us to actually LAN, which actually most of the time we have a number of switches here. These switches actually give us, in the case of Jamam, we are under 105.x network, and under Rumbek we are under 109.x network, and everybody is on one single network, not like Juba scenario. We have Wi-Fi here, which is also under the 10.128, and depending on whether it's Kaya or Rumbek, it's either 105 or 109.x network. And then we have the same setup like in Juba. We have one single network server. It's actually an OGN setup. The server is DHCP AD domino file server, and the names of the server are SS Room DC01, SS Jam DC01, both for the two places respectively. This is the networks we're using. Let's go to Kaya and Guest House. Guest House is mentioned because it actually serves as our fallback office in case security wouldn't allow us to come to office. People will be able to work from the office. So here we have kaya and guest house. They have same setup, 1.8 meter dish for each, and then the same actually bundles for each, 256, 10, 24 with 1 to 8 contention each. Now they have this net cafe setup because it's actually coming right from the. They have single modem each, TX and RX at the same time, and then a kaya is on this, and then guest house is on a different network, and then both of them they connect to a small hub. Actually here, the hub helps us connect our printers here, and then we connect this one back to a Wi-Fi. Everybody is behind the Wi-Fi on a network of 192.168.1.x. Our show is not finished if we didn't show you our power connections, as it's one of the main issues we have here in South Sudan. Juba has actually a solar system that gives us 2,800 watts, and then we have generator at the same time. Both of them, as you can see, this is symbolizing an AND gate. That means both of them are feeding the backup battery bank, which is the BB. And we have here a number of 20 batteries. These 20 batteries are charged either by solar system on off-duty days or by generator on duty days. So both of them send electricity to here. They back up this point, and then we send electricity to the IT server room. We have 24/7 uptime. Rumbek on the other side have similar scenario but without solar system. We have a generator that charges this battery bank, and then the battery bank gives power to the server room. The power is done. Power rationing is happening in Rumbek, not all the time, and also our batteries here are at end of life cycle, so we don't have an uptime of 24/7. The scenario in Jamam the same like Rumbek, but the batteries are okay, the battery bank, and the same thing. But the complete different scenario is in Kaya and the guest house. Both get direct power from the generator, and the power comes, and we have a small UPS only to protect our IT equipment. We have two modems here. This one is the RX modem, and this one is the TX modem. Both of them are connected back to our PSAT in the back here. This modem sends internet back to this is the distribution suite we spoke about. Internet comes on this yellow cable from the RX modem, and then it comes one way, goes two ways out. The green cable connects us back to our router, the Cisco router, and the Cisco router comes in here, this port, and on the other side, traffic comes back from the Cisco router back to our access switch. The first access switch where we're connected actually, and we can see that the router is sitting between the modem and the access switch. The access switch also distributes to other access switches. We have like 1, 2, 3, 4 access switches connected by these red cables, which are uplinks. And from there, we have our server also connected to this access switch. The server is down here as we introduced to you already. And this is the DHCP, the Domino, the DC, and everything is on this one server. The gray cable on the other side connects back to this Wi-Fi device. This is the main Wi-Fi device. It's also acting as the DHCP for the 10.168.1.x network. This device also is connected to other similar devices in different places in the building. And the other devices are configured on repeater mode. They take the DHCP from here and they distribute IP address to the users, mostly affiliates and also OGB staff who wish to be on wireless. Our 2.8 dish with improvised basement to overcome problems of line of sight. On top of the building we have our solar system, which is there. We have 7 of the panels and 7 others are on the opposite side. This is facing west. Those ones, the other ones are facing east. Then they are actually connecting back to our battery bank room, which is this one we will see in a moment. Here is our battery bank. We have 4 of each in 5 rows, 20 batteries altogether. This AVR, which is controlling the power that is coming from the generator to here, and these are the controllers which are actually controlling the power coming from the solar system to here. And these two devices, one is standby and one is active, they change the DC power on the batteries and send them back to our server room. Allow us to share with you some challenges we have here in our office in South Sudan. We have a costly internet which is at the moment $7,720 US per month, and it's going to go up to more than $10,000 in the coming few months as we are going to open new response sites. And South Sudan has no fiber optic cables. We are only just connected via VSAT. There is no power grid, and all entities depend on generators and solar system, which is very costly. No landline telephones, even mobile coverage is not available in some areas of our operation, example Jamam and Kaya. Poor chain of supply, most IT equipment and requirements are acquired from across the borders. We're only 2 IT staff versus 170 users to support. Users are supported via Skype, radio, field visit or mobiles whenever available. Access to the field offices is mostly by air due to bad roads and security problems. Response time to issues requiring site interventions can sometimes delay us 10 days depending on availability of seats on WAP flights. A good number of users have really poor IT skills. It's very difficult to support them remotely. Only 20% of our staff are based in Juba. The rest are based in the field offices. Security is looming risk, like in Malakal. The entire office is actually being looted. Support from region. We receive technical support from the team in Nairobi. They share the knowledge with us. They implement project and stand by our sides. They also help us battle in the investment in infrastructure. They help us with budgetary support, and also they help us with a chain of supply to equipment. We send them to buy them for us. They supervise us, and they help us with some advice on managerial and procedures and policies in HR, and they help us on practical things. And they also do metrics performance management in us, and then they help us on training and capacity building. They motivate us and they do visit us. Thank you very much, and we hope you will enjoy this short report and meet you in our next report.